Hello, class. I'd like to create a video to help you with problem number 8 from your homework. So it looks like we have a clinical trial where 17 out of 824 patients taking a drug complain of flu-like symptoms. We say, suppose that it's known that 1.8% of the patients taking the drug complain of flu-like symptoms. Is there enough evidence to conclude that more than 1.8% of the drug's users will experience flu-like symptoms? Test at a level of significance or alpha of 0.05. Okay, so the first thing we need to do is we have to test to see if we can actually set up a hypothesis test. So let me open up my calculator. And, whoops, I lost it. Here we go. So what are we given? All right, so we have to try n times our proportion times 1 minus our proportion. So n in this case was 824 patients. So I put in 824 times p. We were given 1.8%, so it's a decimal, 0.018. Right, I just moved the decimal 2 places to the left here. And then in parentheses, I have 1 minus p. So I will do 1 minus p, which would be 0.018. And I think that will satisfy this. I press enter. And I get 14.5. Let's see, does it say to round? I'm going to put in 14.5. Oh, I should round it up to 6, maybe 14.6. Right, it says round to 1 decimal place is needed. Okay, so it says because this is greater than 10, right, the sample size, and I assume, the sample size is going to be less than 5% of the population size, right? Think how big the population would be. Pretty large, right? We're only looking at 824 people, so that's going to be less than 5% of the population. And the sample can reasonably assume to be random, right? We're going to randomly just take these patients. The requirements for testing the hypothesis are satisfied, right? Basically, we're saying because these conditions are met, we are allowed to proceed with the question, right? Next, what are the null and alternative hypotheses? Let's say, well, remember, we're testing a proportion, so I'm using p for both of these, and the null is always equal to. So we want to see the null hypothesis would be 0.018, and we want to know, is there evidence to include more than, right? So the word more than means greater than 0.018, right? If we said equal to, I would use the not equal sign. If we said less than, I would use the less than sign. All right, so I press enter. Great. Find the test statistic. Okay, I think I want to use StatCrunch to help me out here. So I press StatCrunch. And I'm going to press stat, proportion stats, 1 sample with the summary. Right, so the number of successes were 17 out of 8, I think it was 852, or 824, you can see over here. Right, 17 out of 824. 824, and I can set up my hypothesis test, right? My null hypothesis was, I think, 0.18, oops, and we said it was going to be greater than, right? That's what we want to test. Let's just double check, right? My p equals, it should be 0.018. Okay, there we go. And the alternative is that p was greater than 0.018, so that looks good. I press compute, and what's nice about this is it provides a z-stat for me and a p-value. So the critical value of the test statistic would be the z-stat. And it says to round 2 decimal places. So we'll enter 0.57, right? Because we have to round up. 0.57. Let me just shrink this for a moment. Check answer. Well done. And then the p-value is the 0.285. So let's enter 0.285. Check answer. Well done. Now, since the p-value is greater than my level of significance, right? My alpha is this 0.05, and my p-value is bigger than this. So if the p-value is greater than your level of significance, we do not reject, right? If it was less than, right, if this came out to be like 0.001, we would reject. But because it's bigger, we do not reject the null hypothesis, and we can conclude that there's not sufficient evidence that more than 1.8% of the users experience flu-like symptoms, right? Basically, we're saying we do not reject HO, so we're going to reject H1. We're rejecting the fact that we think that the proportion is greater than 1.8% of the users, right? Check answer. Well done. So I hope that helps you for problem 8. Thank you for watching.